Algebra 1, like they never even learned it. Okay, so I'm going to kind of reteach it to you right now. Okay, and I'm not going to do an in-depth reteaching because you should remember it from Algebra 1. You should kind of remember it, but I'm going to reteach some of it right now. But if you need extra help, you need to watch a video on YouTube or Khan Academy or something like that if you forgot how to factor. Okay, the first one up here, we can just use diamond factoring because there's no leading coefficient. So we could put 16 at the top, we put negative 8 at the bottom, right? And since it's an x squared in front here, we'll just put an x there and an x there. When you multiply them, that's how you get x squared. Okay. The numbers that go here and here need to be the numbers to multiply to get 16. Right? Well, 16 could be 2 times 8 or 4 and 4. One of those makes 8, right, when we add or subtract them. And that's 4 and 4. So we're going to use 4 and 4. And if there's negatives anywhere in your problem, you're going to have negatives somewhere. And a negative times a negative makes a positive. A negative plus a negative makes a negative. So this factor is x minus 4 times x minus 4. Is how you factor x squared minus 8x plus 16. We're also going to factor the denominator. Okay, and this one is a little different because it has a leading coefficient. So you can't just do the diamonds. We are going to use diamonds, but before you use the diamonds, you have to multiply the a value and the c value. So the number in front times the number at the end. 3 times negative 8 is negative 24. Okay, and that middle number still goes in the bottom, negative 10. Well, 24 has lots of factors. Let's start with 2. 2 times 12, 3 times 8, 4 times 6, and that's, we could do 1 and 24, but it's usually not the 1 factor. Which one of these makes 10? Well, 2 of them do, right? You could do 12 minus 2 or 4 and 6. So at first we said, it's going to be 4 and 6, but in order for it to be 4 and 6, both of these would have to be negative, and a negative times a negative does not equal a negative, so it can't be 4 and 6, so we need to try 2 and 12 instead. Okay. And that will work because only one of these can be negative. We need it to be negative 10, so to be a negative 12 and a positive 2. Right? But those aren't the numbers that go in here. Those are the numbers that we use with our generic rectangle. Right? So review generic rectangle. How do you factor with generic rectangles? You put the first term here, the last term here, and the middle terms here and here. Okay. Your first term is 3x squared. So 3x squared goes there. That's the first term. The last term is negative 8, so it goes at the end there. First and last go diagonal from each other. The middle terms are both of these terms that we found here. These are the middle terms. That's the 10x, but it's split into 2x and negative 12x. Okay, that's the 10x right there. Now we look at what these have in common. Let's go sideways first. What can we factor out of 3x and 12x? They both have a 3x in there, right? 3x goes into 3x, 3x goes into 12x. Now, what can we factor out of 2x and negative 8? Just a 2. Okay. And then, I'm going to look vertically like this. What goes into 3x and 2x? Just an x. I can take an x out of here and here. And then what goes into negative 8 and negative 12? The biggest number, not just 2. 4, right? And it's negative 4 because there's 2 minuses. Okay, so these should tell me what to go in here. And since this begins with 3x squared, how do you factor 3x squared? Because some people it amazes me. Some people put x and x. And I'm like, why would you put an x and an x? There's a 3x squared there. You have to have a 3 in one of these, right? The 3 has to go here. Like, you should just start out like that. Before, not even looking at this, that's a 3x squared. So you have to have a 3x and an x, not just an x and an x. Okay? And, well, these tell you it's 3x plus 2 is one of your other factors, and the other factor is x minus 4. You want to double check your work, see, does 2 times negative 4 equal this last number, negative 8? Yeah, it does, right? And the inside term, 2x, and then the outside terms, minus 12x, so that gives you your minus 12 and your 2, and that gives you your negative 10. So these are factored correctly, okay? Now we can look, what's the same on the top and the bottom? X minus 4, x minus 4. So we can cancel those out, right? And what are we left with? We're just left with this over here, which is x minus 4 over 3x plus 2. So that's what that simplifies down to. And let's talk excluded values. We have a couple excluded values here. X cannot equal something, and x cannot equal something. Why do we have two excluded values? Because it was an x squared. There's going to be two values that make the denominator equal 0, right? The first one is going to be whatever makes this 0, so we go, hey, 3x plus 2 equals 0 to solve our excluded value. So we minus 2 from both sides. 3x equals negative 2, divide by 3, x equals negative 2/3. So one of our excluded values, if I put negative 2/3 in here, that'll make the denominator 0. Can't divide by 0. The other excluded value, what's this excluded value going to be? 4. So we don't have to do work for that one, right? Because 4 minus 4 will give you 0. So those are excluded values. This is our answer. X can be any number we want except negative 2/3 and 4. Okay? So that was 78A. Here's 78B. Okay, so maybe you can try this one. 10x plus 25 over 2x squared minus x minus 15. Oh, and they gave you the excluded values for x does not equal negative 5 halves or 3. So again, you don't want to say, oh, 2 goes into 10, let's cancel that. Or you don't want to go, let's reduce 15 and 25. You can't do that. You just want to factor. So if I factor 10x and 25, what can I take out of 10 and 25? 5. So that's how you factor that one. Okay, you just take a 5 out of both there. Both this one and this one. Well, what would you multiply 5 by to get 10x plus 25? 2x plus 5. Good. Now the bottom one is a trinomial, so we need to figure that factoring out using diamonds and boxes. But immediately I know what goes here and here because it should be the factor of 2x squared. So how do you factor 2x squared? 2x times x. So you know what goes there, okay? The numbers that go here and here should be the factors of 15. Well, let's see. What are our factors of 15? There's 1 and 15, but probably not going to use that. Probably we're going to use 3 and 5. Right? They're not going to make 1, but with this 2 multiplication, they are. So let's use the boxes. Let's go to our generic rectangles. The first term goes first, 2x squared. The last term goes diagonal from it. And then, oh, we didn't do the diamonds. I forgot to do the diamonds, so let's look at the diamonds. For the diamonds, I like to call this the hat method because I'm making like a hat, except this one's upside down. 2 times negative 15 gives me negative 30, so that's what goes on the top. Okay, it's not negative 15, it's 2 times negative 15. And our middle term is negative 1. So we're looking for the factors of 30 that differ by 1. Oh, so it's not actually not 15. We want to do 30. Well, that's 5 and 6. 5 times 6 is 30. One of them has to be negative because we've got a negative in here. We want more negatives because we want it to be negative 1. So these are our x terms, right? So I'm going to put 5x, negative 6x. It really doesn't matter what order you put those in. It'll work any way you do it. So let's do this sideways first. What can I take out of 2x and 6x? 2x, right? You can take out a 2x out of that. And then what can you take out of 5x and 15. Just 5. And then let's do vertically. What can we take out of 2x and 5x? Just an x. They both have an x there. And then what can we take out of negative 6 and negative 15? Minus 3, right? So that should, look, we already set up half of it. So what goes in this part right here? 2x plus 5. And then this half, x minus 3. Look what happened in the top and the bottom after we factored them, right? These two are the same and they cancel out. If you do it right, something should cancel out after you factor. So what do we have left? We have 5 over x minus 3. Okay. And our excluded values, they already gave us right there. Our excluded values, I'll put EV for excluded values. X cannot equal negative 5 halves because if I solve this, I set this equal to 0, I'll get negative 5 halves. Set this equal to 0, I'll get 3. X can be any number besides those two numbers. Okay, so and then part C we'll talk about later. Okay. So for today's lesson, we're going to start, that's a great warm-up for 85, right? So we're going to start 323, number 85. It's a new piece of paper, good. Go ahead and hand the other stuff in the folder. And we're going to look at how do you multiply and divide rational expressions. Here we're going to show how do we multiply and divide rational expressions. Okay, so you know how to simplify something like this. Now let's multiply and divide them. Did we do that one already? 3x squared minus 10x. No, we didn't do that one. Okay, so try this one. So this is a good warm-up one since I just, did 2 examples with you. Now you try this one, and I'm going to walk around and see if you can do this, okay? So 85 says we have 3x squared plus 11x minus 4 divided by 2x squared plus 11x plus 12. And you are going to factor this down using the x's and the generic rectangles. Go ahead and take a second. Factor that. Okay, so for 85, we should have gotten, 3x minus 1 times x plus 4 on the top. That's how you factor that. And the bottom, 2x plus 3 times x plus 4. Right? How many of you were able to get that? Okay, good. If not, work on it. And here's all the work with it that goes with it. So I'm not going to go over it all, but we just did it. It's there. You can watch the video and pause it, look at it if you want to. But that's how you should set up your rectangles. And since you get an x plus 4 on top and bottom, we're going to cancel that out. And so you're just going to get 3x minus 1 over 2x plus 3, with excluded values being negative 3 halves and negative 4. Right? Negative 3 halves and negative 4 for your excluded values right there. Or, because we're going to set that equal to 0 and set that equal to 0, giving us our 2 excluded values. Okay? So that was what you're supposed to get for 85. 86, let's take a look at. And there's a reason why we're doing some elementary, not even algebra for 86. Explain in a second. Share with your class how you would multiply this and how you would divide this. Okay, so some of you went ahead and did it. So 3-86 said, hey, let's multiply 2/3 times 9/14 without a calculator, of course, right? You could multiply straight across, because that's how you multiply fractions straight across, but you would want to do something before you multiply straight across that would greatly simplify this problem, right? What could we do to this problem before multiplying straight across? Cross, cancel, right? 3 goes into 9 how many times? 3 times. And 2 also goes into 14. 7 times. That reduces our numbers greatly, so we don't have to multiply 3 times 14. We just reduced it to 1 times 3, which is 3, over 1 times 7, so the answer is 3/7. We didn't need a calculator. We cross-reduced. Same concept for division, except this time we're dividing. 3/5 divided by 12/25. Okay. Do we actually divide when we divide fractions? No, right? We never divide. We always multiply. So what do we do when we have a division right here? Flip it, right? We're going to flip this fraction and change that division to multiply. We multiply by the reciprocal. So 3/5 times 25/12. It's probably the first time you learned the word reciprocal was when you were learning how to divide fractions. Now that we've changed it to multiplication, we can cross-reduce. 3 goes into 12, 4 times, 5 goes into 25, 5 times, and then multiply straight across. 1 times 5 is 5, 1 times 4, 5/4. So no calculator, very easy when you cross-reduce. Always change division to multiplication and do the reciprocal. Okay, well, we learned that. Why are we doing that again? Because now we're going to apply it to these equations, okay? We're going to look for things that we can cross-reduce, and then we're also going to do division ones, and we're going to flip it over. We're going to change it to multiplication and flip it over and just do the same thing, but just with x's, okay? So let's look at 87 here. 3-87a says 4x plus 3 over x minus 5 times x minus 5 over x plus 3. Is there anything in the same that we can cross-cancel? Right, you want to look at the whole factors, right? Those two are the same, the x minus 5. So let's cross-cancel those. You can't cancel the 3's in here because this has a 4x plus 3 and this just has an x plus 3. They're not the same. Okay, you cannot do that. Don't cancel the 3's. That would be very bad. So it's just 4x plus 3 over x plus 3. Again, you cannot cancel these 3's like this because there's a plus there connecting this, making this one whole factor, and this is a different factor. So that's our answer. We have excluded values. The only thing x cannot equal is what would make this denominator equal to 0. What number would make that denominator equal to 0? -3, right? So x cannot be -3. And that's our answer. Please put a box around your answers because it's going to get like kind of messy canceling everything out. Okay, that's easy enough. Now look at B. X plus 2 divided by 9x minus 1 divided by 2x plus 1 over 9x minus 1. Division problem. First thing we should do with all divisions of fractions is change it to multiplication and flip it over, right? So right away, flip that over to 9x minus 1 over 2x plus 1 times x plus 2 over 9x minus 1. Now check your factors. Is there anything we could cross-reduce? This 9x minus 1, that 9x minus 1 are the same. So reduce, reduce, equals, then we just multiply straight across. X plus 2 over 2x plus 1. Excluded values. X cannot equal. What would make this equal 0? -1/2, right? If you do 2x plus 1 equals 0, subtract 1 from both sides. 2x equals -1, divide by 2, x equals -1/2. So that's the only value that x cannot equal. Put a box around your answer. Part C. Let's try C. 2m plus 3 over 3m minus 2 times 7 plus 4m over 3 plus 2m. Oh, they're all different. There's nothing we can cancel, is there? One of them might be the same. Those are the same, right? You just reverse them. 2m plus 3. Addition is reversible, so these are actually the same thing. Okay. And I might want to reverse this in my answer. I'm not going to write 7 plus 4m. I'm going to write 4m plus 7. That's a little better, right? You're allowed to reverse addition, just not subtraction. And 3m minus 2 is our answer. And m cannot equal 2/3. That's right, 2/3. Add 2, divide by 3, 2/3. Do it in your head. Add 2, divide by 3. Okay, I'm not going to, D we need to do y minus 2 cubed over 3y times y plus 5 over y plus 2 times y minus 2. What's the same? I see a y minus 2, but it's cubed, and I see a y minus 2 over here. Y plus 2 is not the same, right? So there's one factor of y minus 2 here. How many factors of y minus 2s are here? 3. How many of them can we cancel? 1. So we're going to cancel one of these, and if I cancel one of these, I can just drop that down to a 2. Right? Well, one of them cancels with this. So we just get y minus 2 squared times y plus 5 all over 3y times y plus 2. Do we want to multiply this all out and just, square all that, multiply it by the plus 5 and distribute this? No. You never have to multiply your answer out. Just leave it alone. Okay, leave it in factored form. We want the answer in factored form. Okay, E and F. E and F I'm going to let you do on your own because it's just more of that. We need to move on to 88. So if you turn to the next page and look at 88, pulling it all together. So multiplying, dividing. You could do that one really quickly. Multiplying, dividing. Remember to cross cancel. Okay, change the division to multiplication first. I will do C, D, E, and F. I don't think we're going to do all of that. We're just going to do some of that. How much did I do with the other class? Oh, I just did the first part with them. So, since I think a lot of us need more practice factoring, here's your practice for factoring. Okay, so I'm going to give you a few minutes to do some of these before we move on to the next part. So, I'll pause it here. Okay, so here are the answers to 88. Part A is 4/11. Part B, 3/25. Part C, 5 times x minus 2 over x plus 4 squared. Part D, 2 times 2x minus 3 over x minus 5 times x plus 1. And then part E, 5x minus 1 over 2x minus 6, or you could leave it in factored form like that. And part F, 1 over 2x plus 5. Okay, so those are the answers. And if you tried 90 as well, and so you could watch the YouTube video if you need to look at it more. And try that one to make sure you get those answers for those two. Okay, so definitely more practice with factoring. We'll have another worksheet next week to practice some more, and there should be more in your homework too to practice. But right now we're going to move on to the next section, 324, number 97. Okay, so we want to turn to 97. And in this section, we're going to learn how to add and subtract rational expressions. Okay, add and subtract rational expressions. So we did multiplying and dividing. What about adding and subtracting? Okay, and multiplying and dividing fractions is kind of easier than adding and subtracting. Why is adding and subtracting fractions difficult? because you need a common denominator, and usually there isn't a common denominator, and we have to find that common denominator. So we're going to use that to help us here. So if you look at 97, 1/3 plus 2/5, does that have a common denominator? No. So how do we find the common denominator? What do? How do we add these together? Let's review that. 397. So flip over to my new page. 3-97, adding and subtracting rational expressions. Adding and subtracting rational expressions. These are rational kind of means like a fraction. This is section 3.2.4. So if we take the very simple fraction 1/3 plus 2/5. Okay. What is the common denominator of 3 and 5? 15. So we have to get them to become 15, right? So how do we get the 3 to become 15? Multiply by 5 and over 5, right? Whatever you have to do to the bottom, you have to do to the top. Because of that large 1, the giant 1, concept that we talked about last class period, right? If I multiply by 1, I'm not really changing the fraction. So when I multiply this by 5 over 5, I get 5/15. Plus, now I need to make this one be 15th, so what do I multiply this one by? 3 over 3, right? So that gives me 6 over 15. Now that they have a common denominator, we do not change the denominator. The denominator stays the same. Right? We don't add it to be 30. No, it stays 15. And we add the numerators only. 5 plus 6, 11. And if we could reduce it, we would reduce it, but this one doesn't reduce. So that's how you add two fractions with not a common denominator, with unlike denominators. Okay, so let's apply this to algebra 98 here. It says, hey, we have 2x over x minus 1 plus 3 over x plus 5. Is there a common denominator here? No. Okay. So, to make them be common denominators, and these have nothing in common. These are two totally different factors. X minus 1, x plus 5. The x does not count as a common thing at all. So they're completely different, just like the 3 and the 5 was. So what did we do with the 3 and the 5? We multiplied them by each other to make them be the same, right? So if I want to get this to be the same as that, I'm going to multiply it by x plus 5 over x plus 5. Okay. And then I'm going to take this one and multiply it by the other one, x minus 1 over x minus 1. And now they'll be the same. They both have x minus 1, they both have x plus 5. That's the common denominator. So anytime you have something different, you just multiply them by each other to make them to be the same. Okay, so to do this, we're just going to have to distribute here. And yeah, you want to do all this work out. Try not to do it in your head or you'll mess up. 2x times x is 2x squared. 2x times 15 is plus 30x. Okay. And then we can go ahead and do the second one as well. 3 times x minus 1 is plus 3x minus 3. And then for the denominator, we just have x plus 5 times x minus 1. And you never have to multiply the denominator out. Yes, did I mess up somewhere? I forgot to do the other one. 2x squared plus... Sorry, thank you. 10x. Thank you, 10x. I was thinking that was a 15, it's a 5. My sloppy writing. Okay. Okay, you never have to multiply the denominator out. You only have to combine like terms in the numerator. So do not multiply the denominator. We just did it in the numerator. Okay. So now we combine like terms. The 2x squared is right here. That's by itself. Usually you can combine the two middle terms, 10x plus 3x, 13x, and then the minus 3 at the end. So we have a nice trinomial there that may or may not be able to be factored. I don't think this one factors. And again, the denominator, you don't have to multiply it out. Don't make it into a trinomial. We just leave it like that, and that is how you add two fractions that have x's in it. Okay? That one's not going to factor. Okay, and we could talk about excluded values. This would have two excluded values, right? So, but I don't think we need to do that right now. Okay, so let's try another one, 99. 99 says, now add these fractions below. After you had added them, be sure to check to see if the numerator can be factored. You may be able to get a simpler answer. So we can factor these ones. So let's look at x over 3x plus 1. X over 3x plus 1 plus 2x squared minus 2 over x minus 5 times 3x plus 1. You guys will still subscribe to my YouTube channel, alright? Even though I messed up. No, I'm just kidding. I am going to post this. I have a YouTube channel. It's called Teach Math. And I only have like 4 videos on there and like 3 subscribers. But there's no need to subscribe. Nothing exciting coming out. But this will be put on there. Okay, look at our denominators. Is there anything that's alike? Yes, right? They both have a 3x plus 1. But this is missing some of this, right? What is it missing? X minus 5. So all we have to do to get it to be the same as this is to multiply this by x minus 5. So let's go ahead and like multiply this side by x minus 5 for x minus 5. Now they'll be the same. Okay, this both has an x minus 5 and a 3x plus 1. So I'm going to multiply this x times this x minus 5 here, giving me x squared minus 5x. Try not to mess up again. And then I don't need to multiply anything over here because it already has the denominator that we need, so plus 2x squared minus 2. And then the bottom can just be, I like to put 3x plus 1 first and the x minus 5 after. Okay. And then we combine like terms. Well, our like terms are x squared plus 2x squared. Right, that is 3x squared, and then next comes the x term, minus 5x minus 2 over 3x plus 1 over x minus 5. And you might say, oh, we're done because we combine these two into one. But the problem is sometimes you can factor again the numerator. The bottom, we want to leave it in factored form. Do not multiply it out. 3x plus 1, x minus 5. The top, though, they're telling us, you know what, you can factor that again. You can use diamond factoring to do this. But if you just practice, you can skip the diamonds. Because there's a 3x squared, I know it has to be a 3x and an x. Well, 2 is a prime number. So the only factors of 2 are, I'm either going to go 1 and 2 or 2 and 1. That's my only choice. Right? I don't need to use the boxes because when I multiply this, I know I want to, and this, I want to get 5. Well, which one's going to help me get 5? These two, right here, right? Not these two. Because when I multiply 3x times 2x, that'll give me 6x. When I multiply 1 times x, that'll give me 1x, and I can use that to be negative 5. I want this to be negative, so this should be my minus. And I want the 1x to be positive, so my plus should go there because that's giving me the 1x. So 3x plus 1 times x minus 2 is how you factor that. And look, there's a 3x plus 1 on top, there's a 3x plus 1 on bottom, so we can cancel, leaving us with x minus 2 over x minus 5. So sometimes when you combine them, you might have to factor again to take out another factor and simplify further. Okay? And part B. Yeah. So try part B here. It says 9 minus 3x over x plus 3 times x minus 3 plus 2x over x plus 3. What part is the same for the denominator? X plus 3. This part is missing. What can we multiply by to get it to look just like the other side? X minus 3, right? Over X minus 3. Then it will look like the other side. And so I don't need to do anything with the 9 minus 3x, because that's fine. But I do need to distribute my 2x times x minus 3. So plus 2x squared minus 6x over x plus 3 times x minus 3. Let's combine some like terms here. Let's put the 2x squared first, and then negative 3x minus 6x is minus 9x, and then plus 9. All over x plus 3 times x minus 3. Okay, I suspect we can factor the top again. So let's try. And I know that's going to be a 2x and an x, just because that's a 2x squared, so split it up right away. 9 can be 1 and 9, or I'm thinking 3 and 3. Yeah, to make my 9. Why? Because if I just check the outside and the inside terms, 2x times 3 will give me 6x, and then 3 times x will give me 3x. I need to make a 9x, so negative and negative, because both of these need to be negative, so the negative goes here, the negative goes there. All over x plus 3 times x minus 3. They're the same in the top and the bottom now that we factored the top. So that's the same, so my answer is just 2x minus 3 over x plus 3. So that's 99. One more, and that is 100. Okay, 100, we have, okay, these don't look alike at all. 3x squared plus all that, and x squared minus 3x. How do we find a common denominator? Well, guess what we're going to have to do to those denominators? Factor them, right? So we're going to factor them so that we can find something that they have in common. So we need to factor both of these first. Okay, so let's do that for 100. Two more short problems here. 3-100, we have 2x minus 1 over 3x squared plus 13x plus 4 plus x plus 3 over x squared, oops, that's a minus, minus 3x minus 28. So we can't factor the top, just leave it like so. Go ahead and try and factor the bottom. See if you can do it without the boxes in your head. Just try it with pencil. You're working pencil, so just see if you can. These are low numbers, so you should be able to kind of do this in your head. You should definitely be able to kind of do this one in your head. If you want to use the diamonds, you can. That's all you need to use for that one. To factor this one, because it's got a 3x squared, and 3x have to go there. The factors of 4, I want to make a 13 in the middle. When I multiply these two, that tells me, you know what, I should use 4, because 3x times 4 is 12, and that's kind of close to 13. And I have another 1 right here, because 1 times 4 makes 4. So this gives me a 1x, and that gives me a 12x, making 13x. So both of these have to be plus and plus. So I didn't need to use the boxes. I just kind of do that one in my head. This one is x times x, because it's only x squared. And 28, well, the factors of 28 are pretty much 4 and 7, right? 4 times 7 is 28. And it's a negative 3, so let's make that a negative 7 and a positive 3. And so do they have something in common? Yeah, they both have an x plus 4, so we don't have to multiply by that. but this one does not have a 3x plus 1, and this one does not have an x minus 7. So that's what we need to multiply them by. Okay? So they both have this, but this one doesn't have an x minus 7. So x minus 7 over x minus 7, like that. And this one needs a 3x plus 1. So 3x plus 1 times 3x plus 1. Now they are the same. Okay, they all have a 3x plus 1, an x plus 4, and an x minus 7. So how do we multiply? Oh, we have to do like a lot of multiplication. X times 2x. X times 2x is 2x squared. X times negative 1 is negative x. Negative 7 times 2x is negative 14x. And negative 7 times negative 1 is positive 7. So that's how a binomial times a binomial, you should end up getting a trinomial. I could combine these two right here. What is negative x and negative 14x going to give you? Negative 15x, just so I don't have to rewrite the whole thing. This is a really long problem now. And then we distribute this. So let me take the x and multiply it by 3x and 1. X times 3x is 3x squared. X times 1 is 1x. So that times that and that. Now I'm going to take the 3 and distribute it with the 3x and the 1. 3 times 3x is 3x, is 9x. And then 3 times 1 is 3. Okay. And I can combine these two middle terms to be 10x, and the bottom is just going to be all three of them. Let's put 3x plus 1. I like to put the biggest one first, then like, I guess, x plus 4, then x minus 7. Those are the three that are in both of them. Okay, now we need to combine like terms again. 2x squared plus 3x squared is 5x squared. And then I have this negative 15x plus this 10x, so minus 5x. And then this 7 and this 3, making 10. Okay, that's good. And 3x plus 1 times x plus 4 times x minus 7. Don't multiply the denominator. Never multiply the denominator out, just the numerator. And if I factor this, I believe it does not cancel, because I tried it last class period. 5 times x squared minus x plus 2, and this was like x plus 2 times x minus 1, right? And none of those cancel out, so you don't need to factor again. Okay. Yeah. Okay, now the only other thing, which I'm sad that they only put one subtraction problem, they threw it in right at the end like it didn't matter, but this one actually does matter a lot. If you do a subtraction problem, it's one more little step. Okay, it's just a step harder than addition. Addition is really easy. Subtraction is easy, but we have to watch out for the subtraction. Okay. So we want to find a common denominator with x plus 4 and x squared minus 16. This can be factored. Anybody know what x squared minus 16 factors down to? It factors down to, the x squared is basically x plus 4 times x minus 4, right? X squared goes x times x. The 16 positive 4 times negative 4 is negative 16. It's a difference of two squares, a very special type of problem. And the first one is 2 over x plus 4, and then we still have 4x minus x squared up here. What do they have in common? The x plus 4, right? So this one is missing the x minus 4. So we want to multiply by x minus 4 times x minus 4, like that. So to do that, we just need to distribute this 2 times x minus 4, which gives me 2x minus 8. Now this is the tricky part. You see this subtraction right here? It needs to get distributed by both of those, changing both of those signs. And people forget to do that. They're just going to put, oh, it's plus 4x squared minus x squared. No, it's actually minus 4x plus x squared. And that's the part that people forget. Like, this minus is a negative that needs to be distributed to the whole everything up here. So if there's a trinomial up here, it needs to be distributed to the whole trinomial. Right now there's only a binomial up there. Okay, so you got to distribute that negative. And the bottom is just x minus 4 times x plus 4. Let's combine like terms. Well, first we have an x squared. Then we have 2x minus 4x, which is minus 2x, and minus 8 over x plus 4 times x minus 4. And I'm pretty sure this does factor. Top one factors again, so not quite done. What does that factor to? X and x. The factors of 8 are 2 and 4. And it's a negative 2, so we'll make that a negative 4 and a positive 2 to get a negative 2. X plus 4 times x minus 4. And these x minus 4s will be the same, so we can cancel those out. The more you cancel, the better. And so just get x plus 2 over x plus 4 for, that's how you simplify. Okay, so, yeah, this is big. It's a lot. It's fractions, and students tend to hate fractions, and you can't hate them because you're going to use this in calculus when you do limits, and you have to factor and get the limits and stuff. So, and maybe, I don't know, some of you say, I'll never go to calculus, I don't care, but you might have to take it for your major. You never know in college, so you want to know how to do this. Hey, Lucas, thank you. All right, Harriet, this is for you. Thank you. So, yeah, so make sure you know how to factor. Don't be lazy and say, I'm just going to fail that part, because if you fail that part, it's gonna hurt your grade a lot. You're pretty much saying, oh, I don't care if I fail the class. So make sure you factor, and learn how to factor. So I'm making a video on this in case you just spaced on part of it, or you were thinking about something else, or it was just too long, you couldn't pay attention to all of it. Now you can go back and put it on chipmunk speed and watch it at home, right? So you can fast forward through any part you want to. So.